In this video, we're going to be going through the pre-security path again on TryHackMe, and specifically, we're going to be hitting the network fundamentals section right now. If you caught the last video, we hit the intro to LAN video, and now we're on to the OSI model. Believe it or not, we've actually already talked about the OSI model, but you might have missed that video. It was a very long time ago, very early in this channel, so you're in the right place. We're going to learn a lot about the OSI model. So what is the OSI model? It stands for Open Systems Interconnection Model, and this text actually here on TryHackMe goes through everything really that you need to know about the OSI model, and it also lists it in order from application all the way down to physical, but we're going to go ahead and read that right now. There are 7 layers in order from 7 down to 1 is application, presentation, session, transport, network, data link, and physical. And we're going to go through every single layer here in this section. So the answers here, we go with open systems interconnection. There are 7 layers, and the term for whenever information gets added to data is encapsulation. And we will actually be hearing this term quite a bit, especially whenever you get into networking and how data gets added on and how things, how packets get put together. Encapsulation is a term and a practice to kind of get familiar with here. Let's jump to layer 7, application. You should be pretty familiar with the application layer of the OSI model because that's a layer that you interface with the most. Even if you're not in tech or you work in cybersecurity, the end user interacts with this layer the most. Anything with a GUI is operating at the application layer. So of course the answers here are pretty elementary, so you shouldn't really have a hard time putting these in. The answers are also in the text above. The next layer, layer 6, presentation. As the text here says, this is when the standardization starts to take place. At this layer, data is translated to a presentable and consumable form for human people. And so that's actually where we get the answer to the second question on this section. The presentation layer acts as a translator. It also notes that security features such as data encryption, think of HTTPS being the more secure and encrypted form of HTTP, that occurs at this layer. Let's jump one layer down to layer 5, session. This occurs whenever 2 computers or machines on the internet or any kind of network are able to establish a connection. You establish a session, and within a session, those machines transfer packets between one another, and that is how they communicate with one another. We're going to talk a little bit more about packets here in a moment, but that is basically just a chunk of data between 2 systems that is transferred within a session. We'll go an extra layer down to layer 4, transport. And this is kind of where things start to get pretty interesting. We're introduced to TCP and UDP. And this is actually something that we're going to talk about later on in this walkthrough session. We're going to talk about this later on because there's actually an entire room dedicated to TCP and UDP. But at this moment right now, let's be familiar with what TCP and UDP are. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. And these are 2 methods that data is transferred between 2 systems over the course of a session. Now, there are 2 different kinds of methods because TCP is more secure and better for downloading and, kind of better communications and stuff like that. It's way more reliable, and we'll talk about why that is in the next video. But UDP is kind of like it's a one direction thing. Computer A is sending data to computer B, and it doesn't stop to confirm whether or not that data actually arrived to computer B. It just continues to send data. So we have a couple graphics here on this walkthrough, and we see basically the packets are different segments of a specific file. So in this case, the file would be a picture of this adorable puppy, and it is broken into 3 packets, basically containing different segments of the final product, right? And so over TCP, the web server is going to confirm with the computer that it received each packet, so that way the final product is complete. However, with UDP, the web server doesn't care. It is just going to spit out those packets, and hopefully those packets will arrive. Well, as you can see in this example, packet 2 unfortunately was dropped en route, and so the final product was this sad, derpy looking puppy. Still adorable, still fuzzy, but very much incomplete. So running through some of these answers, we'll see that UDP simply doesn't care if data is received. And so TCP would be used for something like an email email client, because obviously you want to make sure that the email makes it to the recipient. However, for something like video streaming, like you watching this right now, it doesn't, I mean, this is actually happening over UDP. It's not that YouTube doesn't really care that chunks of this video might get dropped en route to your device. It's that it needs to be able to send this information fast enough that you can actually receive this video in a high enough video quality. If it's getting to a point where some of those packets are getting dropped, then it'll actually lower the video quality. That's why sometimes you might be watching a video in HD and then it might drop to like 720p. That's because some of the packets it might be noticing is getting lost. And so it will lower the actual size of the packet so that way it can continue to do that. But say you were to download this video, you need a completed video to be downloaded. That would happen over TCP because obviously YouTube wants to make sure that the video you are downloaded is complete and whole and is of the quality that you would like. Now let's jump down to layer 3. All of this happens in a network. We do assume. And this is the layer in which you find IP addresses. And each computer might have a different preference on how they reach each other. Some computers might preference a shorter path and some might prefer a more reliable path. And those may not always be the same. But ultimately, they will find each other using an IP address. Jumping down to layer 2, we get to Datalink. And this is actually where we come up with MAC addresses. Every single device has a MAC address. Unlike the IP address, the MAC address cannot be changed. It is burnt into the networking card of your device. So I hope you like it. There's no removing it. It is with you. And now finally, layer 1, physical. And we are introduced to Ethernet cords, and this is actually something that you might be familiar with. You might have one plugged into your computer right now. But this is like the physical connection. So think of fiber optic cables and things like that. The physical method or the physical medium in which data is transferred. Now, at the end of the walkthrough, you get to play through a game and you get a cool little flag. And basically, to win the game, you have to guess the correct order of the OSI model. It's not too hard, but the flag I'll let you get for yourself. So that is the OSI model. And in the next video, we're going to talk a little bit more about packets and frames, because that is another important concept to be aware of, especially whenever it comes to networking on your entry to cybersecurity or tech, wherever it is that you're coming in from. If you're watching this and the video has already been posted, you can check it out on top. If it has not been published yet, then check the bottom playlist and you can see what other videos from this walkthrough have already been published. With that, I'll see you all next time. Bye.